Welcome to the AASHTOWare Pavement ME Design Fiscal Year 25 webinar number 1 on implementation of MSCR binder grade and damaged dynamic modulus mastercurve. I am Hari Nair, the chair of the Pavement ME Task Force, and I will be your moderator for today's presentation. Today's presenters will be Abu Sufian and Wouter Brink of Applied Research Associates. Like Ben mentioned, this presentation is being recorded and will be available on the AASHTOWare YouTube channel and also on Pavement ME homepage. The other task force members are Ian Risch of Georgia DOT is the vice chair, and Ryan Fragapane, AASHTOWare Product Director, Ben Said, AASHTOWare Associate Product Manager, Nusrat Morshad with the New Jersey DOT, Kumar Dave with Indiana DOT, Dulce Feldman with the California DOT, Jason Simmons with the Utah DOT, Robert Studler with Maryland DOT, and Diana Canadian TAC Liaison and Tom Federal Highway Liaison. First, a couple of housekeeping items. We encourage you to ask questions, and those will be addressed at the end of today's webinar. If you have questions, please click on the question and answer button to send your questions, and we will address those directly after the presentation as time permits. Any questions not answered will be responded to separately. Now, Abu and Wouter will begin the presentation.
Thank you, Hari. Just to start, we'll start with the poll and then proceed with the presentation. So Ben, what are you doing? There we go.
Okay, I'm going to close the poll. Looks like a majority of folks have answered.
Sounds good. All right, thanks, Ben. All right, welcome everyone. My name is Wouter Brink with Applied Research Associates and one of the team members on the AASHTOWare maintenance and support for Pavement ME. Today's, as Hari mentioned, today's webinar is titled Implementation of the MSCR Binder Grade and Damaged Dynamic Modulus Mastercurve features that were released with the software as part of the work that was completed last year. So for the outline of the webinar, first we'll go over the webinar objectives and learning outcomes. Then Abu is going to present on the implementation of the MSCR binder grade. He'll provide a background on the procedure or methods that were implemented, and then go into a little bit detail on the level 3 MSCR binder grade selection as well as the level 2 MSCR binder grades. Then I'll present on the initial damage dynamic modulus mastercurve chart that has been added to the user interface directly in the web application, and go over a few summary and takeaways, and then we'll open it up to question and answers at the end as time permits. First, the objectives of this webinar, they're kind of grouped into 2 enhancement topics. The first one is the asphalt binder selection based on MSCR designation. So the objectives here are to explain the new input level 2 and 3 based on the MSCR binder grade designation, then demonstrate how those have been implemented into the application itself, and how that selection procedure for the default set of level 3 MSCR binders grades are, and display some of the differences between the MSCR binder grade selection and the currently implemented asphalt super pave performance grade binders, viscosity and penetration grade assignment. Then after that, for the damage dynamic modulus mastercurve display, we'll explain the differences between the rehabilitation input levels and how those relate to characterizing the existing condition for fatigue cracking. I'll show the plotting feature for each input level, and then kind of how to interpret some of the results and how that is implemented or used within the overlay design procedure. So the learning outcomes for this webinar, at the end of the webinar, I should be able to explain the difference between the input levels for MSCR binder grades, select the proper user input and lab tests for input level 2 MSCR binder grade, and then also visually inspect and interpret the initial damage dynamic modulus master curve to account for your existing condition. Okay, with that, I'll turn it over to Abu, and he will go over the implementation of the MSCR binder grade. Abu?
Yeah, thank you so much, Wouter. So as Wouter mentioned, the focus of today's webinar is going to be the implementation of MSCR binder grades and initial damage dynamic modulus master curve. So I'll be talking about how we integrated the MSCR binder grade into the AASHTOWare Pavement ME Design software. So you can see a little bit of background in this slide, and then I will discuss a level 3 MSCR and then level 2 MSCR. Yeah, so let's start with the background. So the multiple stress creep and recovery testing, the MSCR test of asphalt binder, involved using a dynamic shear rheometer, the DSR. There are two standards for this test. First one is the AASHTO T350, and other one there's the ASTM standard also, AASHTM D7405. So this MSCR test uses the concept of creep and recovery testing to evaluate how asphalt binder can stand against its potential for permanent deformation. How this test is done, usually a 1 second creep load is applied to the asphalt binder sample, and after the load is removed after 1 second, the sample is allowed to recover for 9 seconds. So after a binder sample is loaded into DSR, there is 1 second of loading period. It follows 9 seconds of recovery period. The test is started with the application of a low stress level that is usually 0.1 kilopascal for 10 creep or recovery cycles. Then the test is increased to a higher stress level that is 3.2 kilopascal and repeated for an additional 10 cycles. So the two different stress levels for this MSCR test is 0.1 kilopascal and the higher one is 3.2 kilopascal. Next slide, please. Okay. So non-recoverable. So what we can get from this MSCR test, the two main parameters from the MSCR test that is computed is the non-recoverable creep compliance (GNR) and the percent recovery %R. So these two parameters are calculated from the applied strain on the asphalt sample under different stress cycle. If you can follow this curve or graph, which is a strain versus time, you can see. After the loading is applied for 1 second, I say there are 9 seconds of recovery period. During the 1 second, the asphalt sample reached to a peak strain, that's gamma P. And during the recovery period of 9 seconds, since asphalt is a viscoelastic material, some amount of strain is recovered and some amount of strain become unrecovered. So we can calculate percent recovery with a ratio of recovered strain and peak strain, as you can see in the graph. And I'm putting special emphasis on the percent recovery here because this is the one parameter as required for the MSCR binder grade input level 2. Next slide, please. Okay, so this MSCR test is the latest improvement to the super pave performance grade that the PG asphalt binder spec, and the new standard is known as AASHTO M332. It has been introduced due to some persistent concern from the beginning of the PG asphalt binder spec, the old spec, which is AASHTO M332, and the concern is the rotting parameter, which is GS over sine delta, may not always adequately characterize the performance properties of all the modified asphalt binder, like the modified binder. Binders modified with polymer, SBS, or oil that most state highway agencies are using nowadays. So MSCR test can capture this high strain region. If you remember, as I described 2 slides back, the test is performed at 2 stress level, and the higher stress level, that is 3.2 kilopascal, can capture the highest strain region where damage is expected to occur due to binder modification with oil or polymer. So this map will show you a picture of how different US state highway agencies is adopting MSCR tests and AASHTO M332. The states that are marked with green are using the new M332 spec with MSCR for their asphalt designation. The states that are marked with orange are using M332 for their polymer modified binder only. The 3 states that are marked with yellow dot, like Texas, South Dakota, and Alabama, are using M320 with M332% recovery test as a plus test, and the black and white test 19 states are using the old AASHTO M320 and other plus tests. So more than 50% of the state in the US has adopted and transitioning to AASHTO M332 and the MSCR test. Next slide, please. Okay, so after the background, I will show how we implemented the level 3 MSCR binder into AASHTOWare Pavement ME Design software. Next slide, please. Okay, so we implemented it in 2 levels. So level 3 was a simple fallback approach and record the least amount of data. This approach is similar to the one that is already used to integrate the performance grade PG designated system into the PMED software. A major difference between the new MSCR spec, which is AASHTO M332, and the old SuperPave high temperature spec, that's AASHTO M320, is how typically grade bumping is done. Under the old system, if the standard grade is a PG64 based on climate and your traffic requirement, and the agency wanted to do a 2-grade bumping, then you have to specify a PG76. So if your original requirement was PG64 minus 22 due to heavy traffic, you have to do you have to use a PG76 minus 22. So you have to use a very stiffer binder, although it does not require for climate or temperature standpoint. In truth, the pavement will never see this amount of high temperature. It was just an artificial way of recovering a stiffer binder by testing the binder at a higher temperature. When using modified binder, this can provide some misleading information because many polymer systems often get softer very quickly at high temperature. Next slide, please. Okay, so in the level 3 MSCR binder grades, you can see there is a high temperature grade, there is a low temperature grade, and there is also a traffic grade that's denoted by S, H, V, or E. Usually S stands for standard traffic, A stands for heavy traffic, V stands for very heavy traffic, and E stands for extremely heavy traffic. And you can see in the second column, these traffic grade S, H, E, and V are based on different traffic levels and traffic speed. And for each traffic level, you have to satisfy, also satisfy a criteria of a maximum GNR value. So according to the new spec, the AASHTO M332, if the agency wants to do 2-grade bumping, you don't have to use a PG76 minus 22 anymore. You can use a PG64V minus 22. Next slide, please. So this was our basis for introducing the level 3 input for the MSCR binder grade in the Pavement ME Design. So the previous PG64 minus 22 would be PG64 standard minus 22. PG70 minus 22 would be PG64 high traffic level minus 22. PG76 minus 22 will be PG64 very heavy traffic minus 22. But this will be dependent upon if you are maintaining the full MSCR specification to specify your binder grades. Next slide, please. So as I said, in the current PMED, there is a default AVTS parameter for the PG binder grades. You can see for PG52 minus 10, we have a default AVTS, and for every binder grade with a definite high and low temperature value, we have an AVTS binder grade. Next slide, please. So this was our basis for the MSCR input level 3. Level 3 MSCR binder grades are based on default A and VTS parameters that are currently in the PMED, and that was used to characterize different binder grades according to the AASHTO M332 specification. So the PG52 minus 10S would be the old PG52 minus 10, and PG52H minus 10 would be the old PG58 minus 10 binder. And as I said, to use this input level, you have to make sure you're following the full MSCR specification, and the level 3 MSCR binder grades with their corresponding AVTS value are shown in the table. Of course, this is like a truncated table. This is only for our lower temperature level -10 and 16. We also have implemented the default AVTS parameter for all other binder grades, for all other lower level temperature. Next slide, please. So I will show you a brief demo of how you can use this newly implemented MSCR binder grade input level 3. Since we have time constraint, I will not show directly from our web app, version 3. I will show you from the screenshot here. Next slide, please. So if you can follow the screenshot, in the mechanical properties tab, you can see you can select dynamic modulus input level 1, 2, and 3. If you select 3, you can see there are 3. There will drop down option for binder category, and you can see PG grade, viscosity grade, penetration grade, or the MSCR grade. So if you use the MSCR grade from this binder category drop down menu, next slide, please. Yeah. Yeah, you can, if you use the MSCR grade, you can see there, you'll see there's an option for you have to choose the high temperature grade, the low temperature grade, and the traffic grade. And if you use all 3 inputs required for your design, the PMED will give you the default AVTS parameter, and that will be fed directly into the next steps of your design. So this is how you can use the MSCR binder grade input level 3 in the PMED. Next slide, please. Okay. So after level 3, I will describe briefly how we implemented the level 2 MSCR binder grades into PMED. Next slide, please. Okay, so for level 2, we have target to collect different binder properties data like complex shear modulus, GSR, phase angle, non-recoverable creep compliance, GNR, percent recovery for different PG and MSCR binder grades. We were able to collect some limited amount of data from Wisconsin, Virginia, and Missouri. I would like to acknowledge this state DOTs for supplying us with data, and we also had some limited viscosity data from Virginia. Next slide, please. Okay, so we did some statistical analysis and the stepwise regression to determine if there is any relationship or a correlation between the default AVTS parameter from the PMED with the binder rheological parameters like binder GSR, phase angle, percent recovery, or GNR. And the result we got is both the AVTS showed promising relationship with the rutting parameter, that's GSR over sine delta, and the MSCR parameter, that's percent recovery at the higher strain level, that is 3.2 kilopascal. Next slide, please. Okay, so the equation you can see in the orange box, that's the equation we have used for we have come up with the VTS prediction based on the data we collected. And we have also plotted the predicted VTS versus the default VTS. You can see in the plot here, the R-square is not great. Still, we can predict 65% of data, but we have plans as more and more binary data would be collected. We have target to update this VTS model so that we can make it more accurate in future. Next slide, please. And same for the VTS, for the 8 prediction, we have come up with this modular equation. You can see it's based on GSR over sine delta, the rutting parameter, and percent recovery at 3.2 kilopascal. And we have also plotted predicted A versus default A. You can see R-square is similar to the VTS prediction. Next slide, please. Okay, so in summary, the level 2 MSCR binder grades is the regression equation that we developed to use to predict the VTS parameter of the MSCR grade binder if the user has lab measured GSR and phase angle data from the DSR testing and the lab measured percent recovery data at high strain level, that's 3.2 kilopascal from the MSCR testing. So this is known as the level 2 MSCR binder grade that's currently implemented in the web app, that's version 3.0 of the AASHTOWare Pavement ME Design. Next slide, please. Okay, so like the input level 3, I want to give you a brief demo of the input level 2. With some screenshot. Next slide, please. Yeah. So in the web app, the version 3, in the mechanical properties tab, if you select the direct modulus input level 2, you can see in the binder category, you will have 3 options in the binder category drop-down menu, the super pave performance grade, the penetration or viscosity grade, the MSCR. You have to select the MSCR binder grade. to go with the MSCR input level 2. Next slide, please. And if you use the MSCR binder category, you'll see you will have option to enter the values that's used in our equation or model. I have to make a note here. The temperature in Fahrenheit, you have to always use your high temperature from your asphalt binder, whether it's 58, 64, or 76. The binder G star is your lab measure G star value. Phase angle is your, it will come from the DSR test. And percent recovery at 3.2 kilopascal will come from your MSCR test. So after inputting all these values or full values, it will use to calculate the AVTS, and this A and VTS value will be directly feed into the next step of your pavement design and analysis process. Yeah, next slide, please. Yeah, so this was my discussion about how we implemented MSCR binder grade into AASHTOWare Pavement ME Design. I'll stop here. If you have any question, I'll be happy to answer at the end of this presentation. Now I would like to hand over to my colleague Wouter Brink to discuss damage direct modulus implementation. Thank you.
All right, thanks, Abu. Yeah, so the next part of the presentation is going over the damage dynamic modulus master curve chart. So if you all remember from last year, we implemented a feature within the user interface to generate your dynamic modulus master curve within the user interface, right? Before you have to run any analysis. So it's one way to check if your inputs are going to, so say if you use level 1 dynamic modulus master curve data, if your master curve is going to converge. So it's one way to help identify and some issues before you even get to the analysis part. And it's a good feature to see the range of mount modulus values that you might have for your design or for your asphalt mix. So for this year, we implemented the damage dynamic modulus master curve, which relates your existing bottom-up fatigue cracking to a damaged modulus. So to go over the objectives again, so for this, we'll explain the differences between rehab inputs level 1, 2, and 3 relative to characterizing the existing condition of your existing asphalt pavement. I'll demonstrate the plotting feature and how the damage or how your existing condition affects the adjustment to your modulus values for the existing layers only, and then kind of just go over some brief interpretation of the damage dynamic modulus master curve for itself. So first, the feature's really only there for, and applies to asphalt overlay design. So where you have an asphalt, basically your asphalt overlay over an existing asphalt pavement. That's really the only time where the damage modulus gets taken into account. And it relates the condition of your existing asphalt layers to the dynamic modulus, and that's defined by your rehabilitation input levels, and they're defined at different places within the application itself. Then it is compared to the undamaged dynamic modulus master curve, which is generated from the other volumetric inputs, and then this directly impacts the existing layer bottom-up fatigue cracking predictions as it sets a starting point for the existing damage. So just to kind of give a quick overview here for the different input levels, for defining the different rehab input levels. So for level 1, this is when you have the best available data. You've performed non-destructive testing on your pavement. You've back calculated your layer moduli, and you have the frequency and temperature values that represents your testing conditions. So for level 2, pavement ME requires the surface condition or distress survey, and from an assessment that you've done, it's typically in percent cracked area, that gets translated to fatigue damage, and then that damage gets translated to an adjusted modulus. And then for level 3, rehabilitation input is a subjective rating of the surface condition, which ranges from excellent to very poor, and each one has a damage index corresponding to each level. One thing you do want to at least consider during this is, especially for the surface condition data is that at the surface, you don't necessarily know whether your alligator or bottom of or cracking that you're seeing in the wheel paths are actually top down or bottom up. So that's something to consider during this, because I'll mention that a little bit later as well. So just to go over rehab input level 1, this is where you have your FWD testing and back calculation. So you go out, test your pavement along the wheel path of the project, including cracked areas. As you measure the asphalt temperature during that testing, then back calculate the mean layer elastic modulus along your project, and that gets entered into the pavement or into the software to estimate the in-place damage. So just to kind of go over what that looks like and how rehabilitation input level 1 was implemented. So first, you start with an asphalt overlay over an existing asphalt pavement. I did not show that in this process, but that gets defined in the different. That gets defined here within your general information and so on. Now we've already defined our structure. Now to set your rehabilitation input level, you need to go to design properties. So I think So first, go to design properties window. Then you go to rehabilitation. Once you're in rehabilitation pill, then you'll see this window pop up with the condition of existing pavement. You want to set your rehabilitation input level to level 1. And the other inputs here, what you'll see is kind of where you enter your mill thickness. Also, you'll notice here with fatigue cracking is grayed out. And I'll share a little bit of that within the next input level 2. Because once we're defined our rehab input level 1, we need to go back to our structure and then enter our back calculated layer moduli. So that's where I've gone here. So now we enter our non-destructive test data for the existing layer. So we go back to our structure, we navigate to the mechanical properties, and then because we have already defined that this is a rehabilitation input level 1, now the screen shows up for the existing layer. Modules of existing AHT layer obtained from non-destructive testing. You can enter your values here for your back calculated moduli, your frequency, and the temperature of your test data. And once you have that, now you can click on Run Dynamic Modulus. So once we click on this button within the user interface, you will see a dynamic modulus master curve. First, you'll see the undamaged curve based on the material properties that you've entered for this particular layer, for the existing layer, and how much that modulus gets adjusted for the existing damage within that layer. So that's kind of what you'll see here is the modulus will reduce depending on what you enter. So just to kind of show some additional examples here, I looked at keeping the modulus. So say we have a modulus of 250,000, and now we want to see what temperature effect has, what the non-destructive test temperature effect is on your actual damaged modulus. So for here in this case, you see the blue lines, the undamaged modulus. Then at a 250,000 PSI modulus at a temperature of 50 degrees Fahrenheit, that's pretty low. So you're going to see more damage or a larger reduction in your modulus. Same thing for as we go to non-destructive tests of 70 and 90. Right, so it just kind of shows these are kind of extreme cases, but I wanted to show how that affects how the temperature during testing affects what your moduli is. And then while keeping the temperature constant, now we're looking at the modulus effect. So it's just similar. I think I used temperature of 70 degrees here. And then as you have your 250 KSI, KSI, 500 KSI, and 750 KSI, depending on the temperature, how that's going to adjust your modulus. Now, this is only for level 1. Now, once we move into level 2 for rehab, the requirement here is from a condition survey. So you've gone out, you've measured your total lane area cracking within the total lane area cracking. It's measured bottom up fatigue cracking. and the amount of cracking here determines the in-place damage of that existing layer. So this is kind of where I mentioned to be careful with trying to identify whether your amount of cracking is top down or bottom up, right? So with top down versus bottom up, that could greatly affect what that condition is. So if the majority of your measured linear cracking is actually top down, and then what you enter into the software, your existing layer is going to have a lot more damage than it actually has. So that has an impact on your overlay, design overlay thickness, and your overall overlay design. So it's something to consider and need to be aware of. What you want to enter is mostly try and separate out the percentage of how much is actually top down versus bottom up, and that can typically figure out through coring at the crack, or estimating a damage based on what you're seeing on your roadway. So just to demonstrate how level 2 is implemented, similar to the level 1 example. First, go through, set your rehabilitation input level, go to your design properties, go to your rehabilitation, then the rehabilitation input level, set it to 2. So now what you'll notice now is, well, FAT cracking here, now it's at a value that you need to enter. So this is where you have your bottom of FAT cracking of the existing pavement before any overlays have been done. So now that's where you enter that value. Now you don't have to necessarily enter anything specific within the layer properties, but if you want to see the damage dynamic modulus chart, we go back to our structure, go to our existing layer and mechanical properties, and then we click on run dynamic modulus, and you'll see a similar curve as for level 1, where you'll have a curve for the damaged or undamaged curve, and then the adjustment to modulus for the existing damage. So this is 50% bottom off fatigue cracks. It reduces it just from a display purpose. It makes it a little easier to see. So, and just to kind of show the impact here of the amount of cracking that you enter. So at 50% gives you the lowest or the largest reduction in modulus. Same with the 35, then 25, 10 is almost no different compared to the undamaged curve. So now for level 3, this is based on a subjective condition rating. That rating determines the amount of existing damage. So as you can see, here's kind of the default values that are implemented. So if your pavement condition rating is excellent, then the corresponding damage interval there is between 0 and 0.2, and then the value that it takes or uses within the software is a value for 0.1, and then that increases as the condition decreases. So if you have very poor, now your damage index value is about 1.2, and that corresponds to about 54.9 or 55% cracking. So it kind of what that corresponds to with the assumed set of calibration coefficients. So now here with the rehabilitation, how to use it in the software, we have the design properties again. We go to rehabilitation, we set our rehabilitation input level, and then you have a structural rating. So when you define the structural rating here, that is specific to the bottom up fatigue cracking. So what's your fatigue condition of that particular existing pavement? I'm not going into the environmental rating here, but that's for transverse cracking. Okay, now once we've changed our input level, now we go back to our existing pavement layer and structure. We run dynamic modulus, and you'll see the same curve, or based on what you have entered, it'll rerun the dynamic modulus, the damaged and undamaged curves. And just to kind of show an example as well here for the different condition ratings. So I have good condition, fair, poor, and very poor, and how those each correspond to the adjustment in modulus. Now some additional items that we need to mention here is at the time of before this analysis or design is run through the analysis process, it's really the initial damage, it's really an initial damage modulus only, based on the factors that's available within the user interface, right? So it hasn't gone through the full analysis process in the flexible overlay methods. So once we're in the analysis process, there's further adjustments that get made for aging, temperature, the depth within the structure, and that's all done during the analysis. And then to really see the kind of the final damage modulus of what it looks like towards the end and after the analysis, that's reported in the output files. So this will be an Excel output report, in the Word output report as well, where you will see the modulus changes over time for each different layer. So what you can kind of tell here within for the existing layers, it's basically the last two asphalt layers. So you can see the modulus adjustments on a monthly, basically the mean adjustments for those two layers. And then for the asphalt overlay layers, you'll also see how that changes for the different quintiles and different layers within the overlay layer itself. So you see there's the different thicknesses and how the sublayering happens. So this is the values that get used in the analysis, which are already adjusted for the aging, the depth, and so on. So just in summary, we showed you the impact of the existing condition on damage and damage modulus between the different rehabilitation levels. Graphic provides a visual representation of how the undamaged modulus is adjusted for the existing condition, to at least get an initial idea to see the impact on how much your modulus is going to reduce. And then that translates to an existing damage from which to accumulate additional damage within the existing layer, which that would also affect your beyond this, but the reflection cracking and so on. Now, to get more details on or additional resources that are available for rehabilitation design specifically, where you can find more of the model, the overall process and how flexible pavement or rehabilitation is performed, plus some of the equations to calculate the damaged adjustments for the damage for the bottom of fatigue cracking, also past webinars, and all training videos related to Pavement ME Design and AASHTOWare Pavement ME specifically is the YouTube channel. So there's different playlists that have been updated and added to the AASHTOWare YouTube channel, which there's basically the training playlist includes basically everything from for using Pavement ME. It goes into the details of the characterizing existing pavement. It goes through new design for both flexible, rigid, overlay designs. Then also past webinars also has its own playlist. So there's several rehabilitation specific webinars on the site, and then also shorter videos or more the designer's corner. These are kind of small 5-minute videos to address a specific item for when using the software. Other places to access this is also in the new web application homepage. So if you go to pavementmedesign.com, there the homepage will actually have direct links to the YouTube site. Okay, so just to quickly summarize and provide some takeaways here, then we'll open up to Q&A. So what we went over today, so we went over the asphalt binder selection based on MSCR designation. So it provided a brief overview of that and how the MSCR binder grade selections were integrated into Pavement ME Design, and then provided a brief demonstration through screenshots here with the selecting the MSCR asphalt binder designations for input level 2 and level 3 binders. Then I also went over did a quick overview of the damage dynamic modulus mastercurve and how that's displayed in the user interface. Provided a very brief overview of the differences between the rehabilitation input levels and how the existing condition is characterized for each one and how that impacts the adjustments to the modulus and the damage index. And then kind of just showed and demonstrated how to show or how to view this within the user interface itself. Okay, with that, we'll open it up to the next poll. There's, I think, 5 or 6 questions within this, so it might take a little longer. But Ben, I'll turn it over to you to open up the poll.
All right, here you go. We're gonna wait about a minute for maybe a minute and a half, and when I see a good percentage of responses in, I will close it then. Thanks. I've got about half of responses in, so I'm just going to keep it open for a little bit longer. All right, it looks like the responses are winding down. So I'm going to close the poll at this time, and we can continue on with the presentation.
Sounds good. Thanks, Ben. All right, first, I just wanted, before we get to the Q&A, just wanted to mention the upcoming webinars for the rest of this fiscal year. So the next one is on integration and use of the recycling options in the Pavement ME Design software. So that's scheduled for December 12th, later this year. You'll be getting a announcement here within the next couple of weeks to sign up for that one. I don't have the exact time, but I think it's around the same, like 11 or 12, around lunchtime. Then the next one after that would be going over the local calibration guide, That one's planned between kind of for the third quarter of the fiscal year, so between January and March. That'll go over some examples of the adjustments and changes to the local calibration guide, and then there'll be a back calculation tool workshop. That one's planned for the fourth quarter, so that's between April and June. And these might switch depending on availability, but definitely the local calibration guide and BCT workshops will be held during this fiscal year. And just as a reminder, all the slides, typically the Q&A and a recording will be on the AASHTOWare YouTube channel. If you have specific topics that you'd like to see as a webinar, please send us some suggestions if that is if it's a high priority item for you. Always open to getting suggestions, and to submit those, you just email it to pavement ME Design at area.com. And with that, I'll turn it over to Hari for the Q&A. And we have about 10 minutes or so to kind of answer some of the questions.
Thank you, Wouter. We got a lot of questions, but Harold is answering one by one. So what I'll do is I'll start from the last. So I think this is for Abu. Do you recommend MSCR for unmodified binder or super pave? Would you give more accurate results considering the AVTS correlation were established based on limited binder data?
What I'm getting from this question is MSCR for unmodified or super pave. I think if it's referring to level 3, I would say our level 2 would be still accurate, although our AVTS correlation were established based on relevant binder data, but AVTS, those AVTS computed from those correlation will come from lab measured data. So our level 2 would be give more reasonable values than the level 3 data, whether it's done on unmodified or super pave binder grade. I think that's if it's meant by the question.
Yeah. Wouter, the next question is, fatigue curve improves for lower moduli. This is true for new hot mix asphalt, but may not be for old hot mix asphalt. Are there plans to adjust the fatigue law according to damage? Not sure, Wouter, but
yeah, I'll plan to adjust the HMAC fatigue law. So this is just for the existing layers to get at least an initial estimate of your damage, right? That damage value is translated to damage to cracking to damage, and then that is adjusted for the modulus. But I don't think it gets adjusted in the, or I mean the.
Yeah, I don't
know. Yeah.
Yeah, I think the question's being asked here is that there appears to be or assumed to be a difference between new asphalt mixtures and old asphalt mixtures. And with Pavement ME, that's not the case. There's one fatigue law, and that one fatigue law is appropriate for all of the asphalt mixtures. The bottom-up fatigue cracking, as you know, is controlled by the lower asphalt layer regarding the, whether it's an asphalt overlay or the existing. And so if it's a rehabilitation design and you have a new overlay and an existing asphalt layer, base layer, the lower asphalt layer, the same fatigue law applies to both.
Wouter, the next question is the calculation of input level 1 damage modulus simply based on a constant ratio between the undamaged AC modulus and the NDT back calculated AC modulus at a certain temperature or frequency? what I think what the question is the damaged modulus and the undamaged modulus, is it based on a constant ratio?
To get from the initial value that's entered, but it's not necessarily constant. But yeah, the initial difference between the modulus, yes, it takes into account that temperature and frequency and where that gets adjusted. But then internally, once we have that initial case, the modulus is within the analysis itself. The damaged modulus is dependent on the temperature and frequency at that different depths, and that also is a function of aging as well. So in the curve itself, it's not going to be a translation necessarily, but it depends on the dynamic modulus master curve coefficients as well.
The next question also very similar. So it says the damaged modulus master curve has always been calculated as a function of the original master curve multiplied by a damage factor. So the curve shifts down without changing the shape of the curve. Do you have plans to use FWD data to see if the slope is affected in any way? For instance, the damaged modulus is closer to the undamaged modulus at some loading frequencies, and in some cases worse or better at other frequencies.
Yeah, we didn't look at that, and it's good to see your name, Dinesh. And we didn't look at that for this because we just wanted to really show what's there, and kind of have it in conjunction with what's being performed for say new AC layers with the dynamic modulus plot itself. I don't think that's been in the works. Kind of look to see if that slope is affected or not.
I think one explanation to the first question that we asked is, I asked because the lower modulus is due to cracking is not the same as lower modulus due to soft binder. I think Harold explained this one. It's the last question, Wouter.
Yeah, I think there's more clarification on the previous one.
Yeah. I think with this we covered every unanswered question. I don't see any new question.
Okay.
Yeah, I think we covered everything.
All right, if there's no more questions, we can wrap up. Thank you to all of our speakers and Hari for moderating. Here's our contact information, my contact information, and staff's contact information. Again, everything will be posted on the website. Of course, more resources, head over to pavements.com for that. And thank you, everybody. We'll see you on the next webinar.